Welcome back to Developers Home. Today we are again solving one more data engineering problem. Earlier we have solved one problem using PostgreSQL, Apache Spark, and in Apache Spark specifically we solved that using PySpark and Spark SQL. Today also again we are solving one more problem, and that is using again PostgreSQL and Apache Spark, or you can say using Databricks. So before starting that, we need to make sure that we have Spark properly installed, configured, so that we can use. So you know that on earlier videos we have configured our system so that we can use that for solving data engineering problems. So we have this data engineering suite, and in that we have installed PostgreSQL, Spark, JupyterLab, MySQL, and MongoDB. So make sure that everything is running so we can execute this problem on our Spark and PostgreSQL. So now going to problem. So we have this problem in which we need to get max salary for each employee. And before this, what you can do is you can also go to this GitHub repo and you can clone this to your local so that you will get that, okay, what are the tables definition you need to create and what are the CSV file we need to load into this table. So you can write query on top of that in PostgreSQL. Same way we need to load the CSV file into our Spark. So also use that CSV file for that purpose. So our problem is in a high level we need to get max salary for each employee. And now if we go to into detail, so first just have a look on table that okay, in that table we have ID, first name, last name, salary, and department ID. Okay, that is fine. Next thing is we have a table with employees and their salaries. Yes, we have a table in which we have employee and their salary. However, some of the records are old and contain outdated salary information. Find the current salary of each employee, assuming that salaries increase each year. So we need to assume that salaries are continuously increasing each year, and we need current salary. It means we'll be only interested to have max salary, and as an output we need their ID, first name, last name, and department. Okay, and we also need to order by this data using employee ID in ascending order. Good. So now I have already cloned this GitHub repo. So now I am going to PostgreSQL, and in that PostgreSQL first I need to create that table. So I'm taking this table definition, creating that table here, and second step is to load data into this table. Table is created successfully. I will just refresh this, and I will have this table here. Now I need to import data, so I will use import export data functionality, and here I need to specify that I want to load this salary data. So I will go to problem 0, employee salary. No, currently I'm on problem 1, so problem 1 and employees data, and I will say okay, just load it. So it will start loading data, and if I go and check progress, I see that data is loaded. What we can do is we can go and have a look on data, so we'll have more understanding on solving this problem. So if we select on this table, so let's see what we are getting. So we see that there are 95 rows in this table, and we have employee ID, first name, last name, salary, and department ID. So we see that for employee ID 1 there is 2 records, and one with less salary, one with more salary. So we can consider that this is the current salary, and it seems like most of the scenario we have 2 entries, and we have one is less and one is more. So that is fine. So we'll not directly solve this problem. What we can do is we can divide this problem in simpler steps. So first thing is what we need as an output, what are the end result. So as an end result we need ID, first name, last name, department ID, and current salary. So what we can do is just put it here. I am just commenting this one that we need max salary here. So I will be like not considering this for now. I will just consider that okay, these are the columns I require for now, and I am commenting rest of all columns. So here I am getting all the required columns. Now, one more requirement is at the end we need this data into ascending order of employee ID. So same thing I will do here using order by. In order by we have need to specify column name, and then if it is in ascending order, by default it consider it as an ascending order, but if in case we need this data in descending order, we can also use DESC, which will give result in descending order. First we'll execute and check, are we getting this data in ascending order by employee ID? So yes, we are getting that. Let's say check with descending order. So we are getting this data in a descending order also, so that is good. So now we need max salary, but with respect to each employees. Okay, if in case we just need max salary, what we can do is, so there is a function in SQL, there are aggregate function in SQL, that those are the functions like max, min, average, sum, count. So these are the aggregates function in SQL server. So let's say I will just use max, and then from this table, and again I will also pass that salary column. So if I do this here and pass salary as in a input of this function, so I will be getting max salary from this table, not with respect to any employees, but in this table what is the max salary. So I will use this, and now if I execute, I will be getting max salary from this table which says 210k. Good. So now if in case I need a minimum salary, I can use that function to get minimum salary. If I want to do average, if I want to do sum, so those are the all functions which is like average, avg, and then sum, which is sum function. So these are the functions, aggregate function, using that we can get these results. So now we can have salary, but let's say I need this minimum salary, or let's consider maximum salary with respect to employee ID. I don't want all other columns, but I need with respect to employee ID. So if I execute this, it will not work, because when you use aggregate function and if you specify column with that, we need to pass group by clause with that. Okay, so now if I use group by as suggested below, so group by ID, so now it will work. Okay, so what we are currently doing is we need max salary with respect to each employee ID, and in that case we need with each employee ID, and that's why we need to pass group by here. And now if we execute, it should work, and it should give employee ID, and with employee ID we'll be getting max salary. So this is done. We have total unique 75 employee, and that's how we are getting. But now here in this scenario, we also need ID, first name, last name, and department ID. So we also need to specify those columns with that, because we need that with those all columns. So we use same max function here. So I will do max here, and now salary with that, and I need to also have this all the columns, and that's why in a group by I will be passing this all the columns. So now what I will do is group by and this. So this will be giving results ID, first name, last name, department, and max salary. So now if I execute, I see that okay, now I am getting this all the values we have done in a descending order. I will remove that, so I will be getting this data in a ascending order. So now I have this data in a ascending order. So ID, first name, last name, department ID, and max salary. So if I want to give this as a alias, and I will say that max salary will be considered as a max underscore salary. So now we'll have our final result, which is like ID, first name, last name, department ID, and max salary. So this is how we can solve this problem. Don't directly go to hard part. Divide that problem in a multiple stages, and first try to solve easiest part, and then continuously add one more part, and that's how we solve this problem. So we understand how all these aggregate functions are working in SQL server, and also understand that how can we do ascending descending based on any column. So our next step will be solving this problem using Apache Spark or Databricks. And in that, we'll be solving this problem using PySpark SQL functions, and we'll be solving using Spark SQL. As we discussed earlier, Spark SQL is similar to NCSQL, and that will be following exactly same syntax, and all the same functions will work in Spark SQL. So if we directly execute this query in Spark SQL, will that work? Yes, that will work. But we just need to follow some of the syntax of Spark SQL that we'll see later. So before that, we'll go to our Jupyter lab. So I have started my Jupyter lab, which is on localhost 8888, and now I am going to here. We have already loaded this data into CSV format. Just copy your file from GitHub and create it here so that we can load this data into data frame. Our first step will be that loading this data into data frame. So what I will do is I will execute this one, which is starting Spark session here, and I will say my app name is program 1. So this will be starting my Spark session, and it seems like my session started on localhost 4040. No, this is not started. It's not correct. Local host. Yes, and this is started on port 4040. I see problem 1 as my app name, so I'm sure that okay, this is running. I have already executed this all the commands earlier, and that's why in a history we see that okay, these are the all completed jobs. But now when we execute, we'll see one more entry here, and if in case that process or that query will take more than few seconds, we can also see that in a current execution. So now first step is to load this data into our data frame. So I am doing that, and you see this is currently running, completed now. So data is loaded into my data frame. Second step is just to make sure that data is correctly loaded or not. So I see ID, first name, last name, salary, and department ID. ID is integer, string, string, integer, integer, so which is correct. Just to make sure on data, we are checking that employee, and we see that okay, these are the all data available here. We are also checking okay, all the data are loaded successfully, and we see that okay, 95 records which is loaded here. So now what we do is first we solve this problem using PySpark functions, and then we'll solve using Spark SQL. To solve using PySpark function, again that same approach will be following. We'll divide this problem into 3 simple steps. First, decide that okay, what we need as in a column. So we need, these are the columns as in a output, and we also need this data in a ascending order by employee ID. So what we can do, that data frame, select we need, these are the columns which is required, and now order by ID. So I will be using order by function here, and then if I will execute this one, I can see this data in the format which we require. Only thing now pending is we need max salary. So same way we use aggregate function in a PostgreSQL. We have same function available here in PySpark, which is again using max. And as we discussed earlier, that when we use these aggregate functions, we also need to use group by with that. And if we are that want to get this salary data with respect to employee ID only, so we need to pass employee ID in a group by clause. If in case we want multiple columns with that aggregate function, we need to pass those all the functions into group by clause. And here we need ID, first name, last name, and department ID with salary, and that's why we are passing this all the columns in group by clause. And at the end again we are doing order by. So let's remove this part, and I'm just executing this one. So now I'm having this all the data which is in a ascending order, and with all the employees max salary. So now this is we are just displaying, but we want to store this data into data frame. And for this scenario, what I'm just doing is just assigning this output into final data frame, so that I will have this data into final data frame. And then again, if you wanna print this data, now we have this all data into final id, final data frame, so we can do all the operations on that data frame and we can get results. So this is how, using group by and max and order by functions in PySpark, we have solved this problem. So now we understand that, okay, how can we use order by in PySpark? How can we use aggregate functions in PySpark? Let's see, if I use min here, it will be giving minimum salary for each employees. So now same result, but instead of getting max salary, I am getting min salary. If I do sum, I will be getting total salary each employee got till now. So if I do sum here or total, so they will be getting so for this employee number one, he got this much salary till now. So these are the all aggregate functions which we can use in a PySpark. Now our second thing is solving same problem using Spark SQL. And for that, first thing is we need to load this data into temporary table or Hive table. So what we do is we use same data frame in which we have loaded this CSV data, and we'll create that temporary table. So this is the steps, which is like data frame dot create or replace temporary view. So this will be creating our table in which now I have data. So I have this table in which I have data. So now we can write same SQL query which we wrote in PostgreSQL. Just consider that when we execute any Spark SQL, we need to write SQL context.sql. So this understand that, okay, whatever written inside this, which is Spark SQL. So for example, if I want to get select star from all the table, so this is how I will execute. And now if I use same function which we have used that, which is like id, first name, last name, max salary, and department id, from that table group by id, first name, last name, department id, and order by id. So I will be getting final results. Same way, this aggregate function, if I do minimum, I will be getting minimum salary for each employee. If I do a descending order, so I will be getting this data into descending order. So we understand that PostgreSQL, which also uses most of the syntax in PostgreSQL and most of the functions which is related to NCSQL. And same way, Spark SQL is also related to ANSI SQL, and most of the functions which we use in SQL, basic functions, aggregate functions, and all other functions that are also supported into Spark SQL. So we can write same query and get that result. So if you're familiar with SQL Server, or if you're familiar with any of the SQL database, and if you understand how to write queries in SQL language, so you can directly use Spark SQL to resolve this problem. Or there is a one more way, which is using PySpark functions. So we have solved this problem using these three ways: PostgreSQL, Spark functions, and Spark SQL. Same way, you can also solve this problem in a Databricks. As of now, I am using open source Apache Spark, but you can also use Databricks and you can solve same problem there. So this is how you know that we resolve our problem number one. So in our next video, we'll be solving one more problem. Till then, see you and thanks for watching this video. If you have any questions, please comment in a below box and we'll discuss on that. Thanks. See you again.